Alright, to help keep the video shorter, I wanted to go ahead and split this up, and we're going to pick up now with number 7. So on number 7, you can see again it's not set equal to 0, so I'm going to add 53 to both sides. Hopefully you're picking up on the fact that you're just switching the signs when you do the inverse operation across the other side. So hopefully you can just see that I just switched it from a negative 53 to a positive 53. So again, list your A, your B, and your C. Find your discriminant, which is the b squared minus 4ac. So b squared, that would be 28 squared minus 4 times 53. So at this point, hopefully you're recognizing that it's a lot of pattern and repeating and getting really good at it. So I already typed in our 28 squared minus 4 times 53, and I get negative 64. Perfect square, but it's negative. I wonder what's going to happen now. So now back to our quadratic formula. X equals opposite b, so negative 28, plus or minus the square root of the discriminant all over 2 times a. So now I've substituted. I have square root of a negative, so I'm going to go ahead and put an I out front. But also recognize that the square root of 64, we should know that one, the square root of 64 is 8. So that means when I simplify, I'm going to have negative 28 plus or minus 8i, no radical at all because there's no need, it came out of the radical, equals 2 times 4, which is 8. But remember what I explained before, that if the 3 numbers here on the outside, not including, sorry, that's a terrible heart, not including any radical, have a common factor, then we will reduce. So 28 and 8 and 8, if you started by 2, because they're even, you're going to find that what you get, so I'll kind of show you. If I divide all these by 2, then I'm going to get negative 14 plus or minus 4i over 4. But notice all of these are still even. So that means that there was another factor other than 2, and that is 4. So some of you might recognize that right away, but if you do start with 2, you'd have to simplify again, okay? But if I use a 4, so if I divide all of these by 4 to reduce, then I'm going to end up with negative 7 plus or minus 2i over 2. And note that you cannot reduce the 2 and 2 because this is like the whole numerator over 2. So we're not going to look there. Remember, all 3 have to have a common factor in order to reduce. So I'm going to go over here now to number 7 on Delta Math. And I'm going to get rid of that other stuff because it won't show up on yours. Well, it shouldn't have that up there. But anyway, we're going to type this in exactly how we see it. But if we do not, I just want to show you what happens. If you don't type in parentheses, and then when you hit divide, only the 2i is going to be in the fraction. So we want to go ahead and start with parentheses. So it will include all of this, select your plus or minus, in the numerator. And then it finishes up there. Now we can do divided by 2. So that's what you'll need to do in Delta Math if you've got a numerator like that. Make sure you do it in parentheses. All right. So you can see that here they reduced. Here they show you that they're actually factoring out a 4. It's actually the same thing, factoring out a 4 and then canceling it out. But there we go. All right, that's 7. Go ahead and pause it and do number 8. All right, for number 9, we need to still set it equal to 0. I'm going to move, this is my linear term. My linear term needs to go in between my quadratic and my constant. So it's going to be x squared minus 4x plus 29 equals 0. So if you aren't quite catching on to what I'm even doing here, I'm still just subtracting 4x from both sides so it's equal to 0. I just need to put it in my ax squared plus bx plus c order. So a is 1, b negative 4, c is 29. For my discriminant, negative 4 squared minus 4 times 1 times 29. And again, I'm just plugging it into that b squared minus 4ac formula. So remember, I told you if you can go ahead and square this in your head, cool. So that's negative 100 this time. So x equals opposite b. So my b is negative 4. So the opposite b of 4 is positive 4. Plus or minus the square root of the discriminant all over 2 times a. So now when I simplify, 4 plus or minus, again, I out front because I have square root of a negative. Quadratic formula, it really is, if it's in standard form, ax squared plus bx plus c, it's the best option if you have imaginary and irrational solutions. So, because you can't factor and square root property won't work. Keep in mind, factoring or in square root property won't work, so quadratic formula is always going to be better. So square root of 100 is actually 10. So I'm going to write 4 plus or minus 10i over 2 times 1 is 2. Oh, but look, all three have a common factor of 2. They're all even. So I'm going to divide each of these by 2. 2 divided by 2, oops. 2 divided by 2 is 1. 4 divided by 2 is 2. 10 divided by 2 is 5. So I'm going to have 2 plus or minus 5i, but I do not need the over 1 because anything divided by 1 is just itself. So that means my answer is 2 plus or minus 5i. So 2 plus or minus 5, and then just hit the I key. And we're good. All right. So go ahead and pause it and do 10, and I'll pick back up with 11. All right, for number 11, we're going to move our constant term over. So I'm going to have minus 3 equals 0. My a is 4. My b is 4. My c is negative 3. So hopefully you're catching on. This repetition is to help you get better and better. So b squared minus 4 times a times c. So if you recite these formulas out loud or over and over in your head, you'll just memorize it better. So type in 4 in parentheses, or you can just do 16 because we should all know 16, or 4 squared is 16. Minus 4 times the negative 3. That gives me positive 64. Oh, I got a perfect square this time. Oops, I should put that here. Not here. So x equals opposite b plus or minus the square root of the discriminant all over 2 times a. All right, so now I have negative 4 plus or minus 8 over 8. So now, what kind of solution should we get here? They should be rational because I don't have an I or a radical. So remember, like we did before, we're going to split this up into 2 separate, like we did numbers 1 and 2. Negative 4 plus 8 over 8, and I have negative 4 minus 8 over 8. We're going to just simplify the numerators and reduce. So negative 4 plus 8 is the same as 8 minus 4. So 4 over 8 gives us 1/2. Negative 4 minus 8 is negative 12 over 8. So if you're not great with integers, just type it in. That's no problem. Negative 4 minus 8. So this is negative 12 divided by 8, and then I can hit math, enter, enter. And you can do the same in your app. So therefore my solutions are 1/2 and negative 3 over 2. So notice we're using curly brackets for these. Technically, we could use curly brackets for these too. Technically, this is 2 solutions, by the way. 2 plus 5i and 2 minus 5i. Okay? But it's perfectly fine to not use the curly brackets on your solutions if they're rational. But let's see how they want us to type it in here. So here, because I have 2 solutions, I'm just going to hit plus. That automatically pops up the curly brackets. So one of my answers was 1/2, and the other was negative 3 over 2. And we're good. We got rational solutions that time. But remember what that means. If I get rational solutions, I could have factored it, right? We'll spend some time tomorrow and the next day looking at how can I look at it and tell if I can just go ahead and factor. That would be really nice, right? For those of you pretty decent with factoring. So pause it and do number 12. And we're going to pick back up here with 13. So I'm going to move my linear term over here so I'll have it in the correct order. Remember, it's the same thing as just subtracting 4x from both sides. So x squared, subtract 4x, plus 76 is equal to 0. List your A, your B, and your C. Find your discriminant. So I'm going to type it in now. Negative 4 squared is still 16, but make sure, negative 4 squared minus 4 times 1 times 76, and we get negative 288 this time. That looks like something I'm going to have to put in my calculator. So x equals opposite b plus or minus the square root of the discriminant all over 2 times a. Now when we simplify, I know the bottom is 2. Let's talk about what to do here. So it's the square root of a negative, so I'm going to put an I out front. And I do not know, like if we type in 2 square root of 288, I'm pretty sure it's just an irrational number. Oh yeah. So that means I'm going to go to my y equals and do my 288 divided by x squared strategy, because that is way easier. So remember, I'm looking for the last whole number ordered pair, integer ordered pair. So 1, 288, that's an integer ordered pair. So is that, but that's another one. We want to find the last one down the list. Let's see if there's any past here. Oh, there is. 12 and 2. Any more? Doesn't look like it. Nope. Once I get past the 1, like a number less than 1, I can't find one. So my last one is 12 and 2. So I'm just going to do a quick recap. That y1, we did 288 divided by x squared. The last integer ordered pair was 12 and 2. We always write it in the form x root y, so we get 12 square roots of 2. So I'm going to come over here, and now just don't forget about your I. So this is 12i square roots of 2. And now I'm going to draw my heart on the outside, not including the radical, and look for a common factor. All 3 of these are even, so I'm going to divide using 2. So 2 into 4 is 2. 2 into 12 is 6. 2 into 2 is 1. Look back at number 9. Remember, when the denominator was 1, I didn't need anything in the fraction, or anything in a denominator. So I'm just going to be left with 2 plus or minus 6i square roots of 2. And don't forget that I there. Okay? So I'm going to come over here, and that's what I'm going to type in. 2 plus or minus 6i square roots of 2. Okay, that happened again. Nope, I'm not even looking at the right problem. Look at me. I was trying to plug that in for number 12. No wonder it wasn't working. All right, so here I go. Try that again. 2 plus or minus 6i. Oh, that's number 14. Look, I'm going to make a mistake again, y'all. I'm on 13. About to put it in for 14. Don't make my mistake. All right, here we go. So 2 plus or minus 6i square roots of 2. And it's right, because I plugged it in for the right problem. All right, so go ahead and wrap up the assignment by making sure numbers 2 through 14 even are done. Good luck with your assignment.